Okay. So I have shared my screen. You should be able to see my slides. So let's first try to understand what is MapReduce. MapReduce is a software programming model which is designed to process the large scale distributed data. Okay. Using HDFS, we saw that the data is being, the last file is being broken into blocks, and these blocks are getting scattered across the cluster. Now, when you want to do some sort of processing, the computation, that's where MapReduce comes into picture. Okay, that's why we say it's a programming model which is used for large scale distributed data processing. The data is already scattered across the cluster. Okay. What was the inspiration for us to go and develop the MapReduce? That is Doc Cutting, who developed this MapReduce. For him, he was primarily working on an open web search, and he was facing problem. How do we handle the processing where the data is stored across multiple systems? That's where he was looking for a solution. And in the meantime, Google published a research paper called MapReduce in the year 2004. Based on the paper content, dog cutting and another colleague of dog cutting, that is Macarella, I forgot that name, Caffarella, I think. They both developed this MapReduce. The concept of MapReduce, the Apache MapReduce, is more or less the same what we see in Google's research paper. Okay. The Google themselves, okay, were inspired to develop MapReduce based on one of the earlier functional programming called Lisp. In Lisp programming, they had a concept of map and reduce. Okay. By looking at those concepts, they said we need to develop something similar to that for processing distributed data. That's how they developed MapReduce. MapReduce is a programming model, and the programs can be written in multiple programming languages. One of the language happens to be your Java, or you can use Python also. You can write the programs in PHP and Ruby. These are scripting languages. Okay. At a high level, if you see this image here, it actually takes input data. Then there is first phase. MapReduce, actually, the processing happens in two phases. First phase is called a map phase, and second phase is called a reduce phase. The input data is first given to the mapper phase, which does some sort of processing. The output, whatever is generated, we call it as an intermediate data. This intermediate data is fed into the reducer phase. The reducer phase takes that intermediate data and process it and generates the final output. Okay, are you with me so far? Okay. Let's look at the architecture of MapReduce. When we looked at the architecture of Hadoop, we were talking about two components. One is a HDFS and second one is a MapReduce. So we already saw how a HDFS architecture looks like. It primarily has a master and a set of slaves. Similar to that, since whole of Hadoop follows a master-slave architecture, even in MapReduce, we have a master-slave concept. Our master is a job tracker. The master is called as a job tracker. And when it, give me a minute. ಇಲ್ಲಿ ಹೊಡೆಯುವ ಬಿಟ್ಬಿಡು ಲೇಟ್ ಆಗಿದೆ ಅದಕ್ಕೆ. The master is called as a job tracker, and the slaves are called as a trackers. And job tracker, that is a master, needs to continuously in touch with your name node to know the location of the files. When I talk about the location of files, the name node would be sending the location of the blocks where a particular block is stored. That's the information that is required for job tracker to schedule the jobs. And clients are the one who would be interacting with the cluster to avail the services of Hadoop. It could be some sort of computation request. So one example that I can take here is, so in previous HDFS, we stored a file called file.txt onto the cluster, and there our file size was around 200 MB. Okay, let's say now somebody is asking us saying that, can you please let me know how many lines are there in this particular file? Then there is a computation request that is coming into picture. That's where we use a MapReduce. For storing, retrieval, adding a file, deleting a file, updating a file, that is appending a file, for all that HDFS comes into picture. When you want to do some sort of processing, it could be a simple search, okay, or it could be a processing request like counting the number of lines in this particular file. Then MapReduce comes into picture, which means I need to write a Java program for this.
Okay.
Okay, or you can even write a simple Python script.
Okay.
Okay, now client is the one which will have that Java program, and then that Java program would be submitted to the job tracker for the actual execution. Job tracker has a final authority, and it is the one which will control the whole of execution. Okay, what it does is once a computation request comes, it breaks that particular computation request into smaller jobs. Okay, sub jobs, which we call it as a task, and each of this task is assigned to one independent task tracker. Okay, this is how we are distributing the work to set of slave nodes. Okay.
Okay.
Okay, let's come back. So, client interacts with job tracker for submission of the computation request, and it also interacts with the slave nodes for retrieval of the results. Okay, it needs to store the file and it needs to retrieve the results. And whenever a particular task tracker that is executing a given task, it is required to send continuous status update to job tracker. We will see those things in later slides. Okay, at high level, this is how the architecture looks like. You have a master called job tracker, and you have a set of slaves called task tracker. Here we have only 4 slaves, and job tracker in turn talks to the name node to get the location of the file, and it also interacts with the client to understand what is a computation request. It is a one which will update the client about the ongoing jobs execution status. And when it comes to the interaction with the task trackers, right, it schedules the jobs, that is task, it monitors the ongoing execution, and once it is completed, it retrieves the data and goes and updates the client. He's sort of a coordinator. He's not going to do any sort of computation. He is only the coordinator. Okay, so we can have multiple clients talking to the same cluster where multiple computation requests might be happening in parallel. Let's come to the internals of job tracker. Job tracker internally have a component called scheduler. Okay, this is a core component. Okay, here I have shown scheduler outside, but it is actually part of your job tracker. Recall our name nodes components. One of the component was a block management. Okay, we explicitly talked a lot on block management. Okay, similar to that, we have a scheduler here. Okay, this scheduler is internally well integrated into the job tracker, and job tracker as one single entity is actually interacting with a set of task trackers. Periodically, task trackers are required to send a message called heartbeat message. This basically sent by the task tracker to the job tracker to inform that a particular task tracker is up and running. Along with this status update, it is also updating the ongoing computation task execution status info. If a job tracker has assigned, let's say, task A, okay, what's happening with this particular task? That sort of status is continuously sent by task tracker to job tracker, and it is periodically sent. When I say continuously, it is periodically sent, and that periodicity is every 3 seconds. By this, job tracker knows which all task trackers are doing what job and how much resources they are consuming. This information is finally forwarded to the scheduler, which is part of your job tracker. The scheduler collates all this ongoing task execution status from multiple task tracker, and then decides how a new job should be scheduled. Are you with me? It's like, let's say I am a project manager. I have 5 engineers. Okay, let's say I have assigned each one a task in the beginning. Let's say I have assigned task 1 to first fellow, task 2 to second fellow, and task 3 to third fellow. Let's say last 2 fellows are free. Are you there, Skrijit? Kshitij? Hello? Shitesh, are you able to hear me? Yeah, okay, fine, cool. Okay. So let's say I have five engineers and one project manager. Project manager is your job tracker, and E1, E2, E3, E4, E5 are your.
Hello.
Yeah, tell me.
Yeah, could you repeat the last couple of seconds? Like I couldn't hear you.
Okay.
After the task. It,
Yeah, I'll come to that. So job tracker, it is continuously getting a heartbeat messages from task tracker, and this is sent periodically. That is every 3 seconds. This heartbeat message will serve two purpose. One, to say to the job tracker that a particular slave node task tracker is up and running. Okay, it is alive. The second one is it also sends the task status information. When I say task status information, the task tracker is updating the job tracker saying that what is it currently doing. Okay, every task probably will have a identity, okay, a id like similar to our block id. With respect to that id, it will say how much computation has been done. A continuous status update is going to the job tracker, which is internally used by the scheduler to say which particular slave node's task tracker is busy, which particular slave node's task tracker is free, and based on all this information it will be able to serve the new job that is coming in. Okay, if there is a client C2, okay, let's say client C1's job is going on, execution is going on, there is a new client C2 is coming for another computation request. Let's say this is how it looks like. You have this job tracker, which is your program manager. He has assigned a task T1, T2, T3 pertaining to client C1, and all these three engineers are busy. Let's say because of redundancy, both the files that is required for client 1 and client 2 is stored on all these slaves. Now when a scheduler wants to schedule the job, it can choose E5 and E4 and E5 for the C2's job execution, which means this would be T4, this would be T5 task, but T4 and T5 belongs to second job. These two belongs to second job. This is one job and this is one another first job. So this way two map reduce computation can happen in parallel. This is a decision that the new task assignment all is done by your scheduler. What is a scheduler? It is again a piece of software which will take various parameters as an input, and it generates an output which would be a list of tasks to be executed and the node where it needs to be executed. Okay, it's a
okay.
task assignment list which is again given to the job tracker. Now job tracker knows, okay, what are the tasks and which are the slaves on which the task needs to be executed. With the help of its scheduler, the assignment, it will go and assign the new task to E4 and E5. From now on, job tracker is the one which will continue to monitor the ongoing execution.
Okay.
Okay, now let's try to understand the scheduler's internal now. So internal means like importance of that. Hadoop implements a task schedulers as a pluggable component, which means you can take out the scheduler and you can insert another company's scheduler. So the way we do in our automobile, right? If you have a battery, the car has a battery. Battery is just one component, but you can have the same battery coming from multiple vendors, right? If you think Amaron
Yeah.
battery is far better than Exide, you can always take that out and put another company's battery, that Amaron battery. So by this, your life of the battery will be probably 1 year more. That's what they say in India. Okay. So that way, this scheduler itself is a pluggable component. You can take it out and you can put a different scheduler. Okay. By default, Hadoop supplies three types of schedulers, three variants. One is called first in, first out, capacity scheduling, fair scheduling. We are not required to know at a user level how these schedulers are working. These are more of, internals of job execution. We are not required to know. But what you need to know is the scheduler is a pluggable component, and the type of scheduler that we are going to use will have a big impact on performance of the MapReduce execution.
Okay.
Okay, and scheduler is a one which controls the order of task execution, which task should be executed first and which task should be executed next. That is what is decided by scheduler. When we take a bigger job and break it into smaller ones, okay, the order of execution is decided by the scheduler. And resource allocation, which task should be executed on which slave node, how much resource should be allocated, all those things would be decided by this guy. Because
Okay.
of that, the role of scheduler has a big impact on MapReduce performance. and the time it takes to complete a given job execution. So this, I would say, a little advanced topic. If you don't remember all the content of this particular slide, that is still okay. What you need to know is there is something called a scheduler, which is a pluggable component, and by default, Hadoop supplied this sort of thing, and the type of scheduler that you use will have an impact on your performance. Okay.
Okay.
Yeah. And remember this heartbeat and status info. This we already studied in HDFS. It's similar to that, which means now if you try to look at the HDFS and this one together, there are two status messages being sent by any slave node. One by the data node daemon and second by the task tracker daemon. The data node daemon is sending the status update, that is heartbeat message, to name node, and the task tracker is sending a heartbeat message to job tracker. Okay, now let's come to the actual model of MapReduce. How MapReduce works. MapReduce takes key value pair as input. We'll see what is key value pair. It takes key value pair as an input and produces a list of key value pair as output. What is key value pair? We saw in earlier class, right? Student, roll number and name. This is the best example of key value pair. If you take a given class, any class in any school, it will have a set of students, and each of these students are identified in a class by a roll number. And each of this roll number, the student will have a name. The names can be same, but roll number cannot be same. Right? Similar to that,
Right.
in MapReduce, we have key value pairs. But the only difference here is, here the keys can be same. That's where we do a operation called combine. Okay, the keys can be same. If I say roll number 1 in a class, it can be only 1. But here, when I take some value as a key, okay, it can repeat. To avoid the repetition, we have a process called combining. I'll come to that later. Just remember that class is a good example for key value pair. A roll number and a name. Name can repeat. In a class, roll number cannot repeat. But when it comes to MapReduce, the key can repeat. Okay. MapReduce takes the data, the whatever data we have, right? The data has to be in the form of key value pairs. And the MapReduce, it's a software program, right? It takes this input data, which is in the form of key value pair. It does some sort of processing and it outputs. Okay, again in the key value pair. The only difference between the output and input is the output of this MapReduce execution is a list, which means it can have 0, 1 or more than one elements in that.
Okay.
Okay. I'll come to an example. When I talk about the mapper phase, I'll come to that. Okay. So the whole MapReduce, as I said earlier, it is done in two phases. One is called a mapper phase, and second one is called as a reducer phase. What is a mapper phase? What we do in mapper phase, we organize the input data to be processed. Okay. In reduce phase, what we do is the data that needs to be processed in the reduce phase, right? We try to organize that input data. And how do we achieve this a transformation of data from the input source to the intermediate thing? We have a Java function called map. This is a method in Java. We call it as a method. The user needs to write source code for this. We need to write the program for that. Whatever code we write, that is a program that would be executed on a given key value pair, and the code that we are going to write, that is the one which will decide what would be the output of a map method. Okay. Mathematically, I know you are not able to clearly understand what's happening here. I'll come to an example. Mathematically, we write mapper phase computation in this form. Map of k1 comma v1. K1 is a key one, first key, and v1 is a first value. And the output of this guy is a list which will have a set of keys and values, and these set of keys and values are different. Okay, let me take a simple rhyme, okay, which I'll show it to you in my this one also. Do we have, yeah, I have this rhyme here. Let me take this rhyme. So yesterday I took the same rhyme for somebody else. Okay, let me say this is a text file. Okay, and these are the line numbers that I have added. It has 10 lines. Okay, this is your text. This is Baba Black Sheep poem. So ideally we'll not have line numbers like this. We will only have the English text. Baba Black Sheep, have you any wool? Lesser, lesser. This is what we will have. Now, when we try to do a map, let's say we have a problem at hand where we need to count a given word. We need to identify a unique word and see how many times this particular word is occurring in a given text file. Let's say this is a text file, which means I need to see how many times ba is occurring in this. Ba one time, two time, three time, four time. Now black one time, two time. Okay, this is how the output should be generated. Somebody has asked us to create this list. Black two times, then sheep how many times? Baba Black Sheep one, two. I think it is only two times. Okay, two. Like this, we want to generate the list for all the words that are there in this particular text file. Are you with me?
Yes.
Okay. Let's say this is a task that somebody has given it to us. How can we do? We can do this computation using MapReduce. We can do this computation manually. We can do this computation using a simple Java program, which will open the given text file and start counting the words. First, I will find the first word and I'll keep on comparing all the words in the file and see how many times ba has come, and I'll start outputting the each unique word and how many times it has occurred. That can be done. But since we are talking about the MapReduce, it needs to be executed in a little different format. The Hadoop is providing us a MapReduce framework, and we need to understand how it is processed on this particular framework. In mapper phase, what will it will do is as I said, in mapper phase, the input is a key value. The first key value is your first line. The key is 1, the line number, and the value is this one. So this is how it will be. First time when the map function is executed, it will get something like this. Okay, this is what gets executed. Since my map input is this, I want to count the words, right? Which means I, as a programmer, okay, nobody has told us, I am writing the logic. I need to generate the list wherein I'll break the input line into multiple words. So the output would be a list. Okay. Okay. This is how it would be. Okay. I'll repeat this so on up to cool. Okay. So I want to generate from this map method whatever is taking key as like 1 and the text as a value, right? I want to generate a list something like this. Now, how do we generate? Let's say I have given Java code to you, and if you put that Java code in this map method, the map function, you are going to get an output in this format. The word and how many times it is occurring. That is one time. So now, since we have 10 lines here, in the mapper phase, the map method would be called 10 times. So how many, whatever is the number of lines, those many times the mapper method would be called. So the second time the mapper gets executed, this is what it will get. So I'm removing the special character that will make our life simple. I'll come to that. Okay, so I know this is little tricky for the first time. So now if you observe, I'm not doing anything with a key. I'm just ignoring that. It's of no use to me. Okay, so this is how the second time the map method is called or like executed on the second line, the output would be something like this. This will repeat for all 10 lines. Like this. Okay, at the end of mapper's execution, you actually have a data in this form. Is this clear? Any questions here?
Yeah.
Okay, so let's
No.
come, yeah, okay, let's come back to this. So we said the mapper is organizing the data, input data, so that it can be processed in the reduce phase. And how does it do? It basically has a function, a Java method called map, and for that we need to supply a key value from the input file, and as output it will generate a list which is of a different key K2 and a different value V2. So if you see now our text file, this is what it has done. It has taken a line by line, and the map method is called on every line of our input file, and it is generating the output, which is a list, and the values here and here are different. Here the key was 1, here the key is bar, here the key is black, here the key is wool. This is K1, this is K2. Within the list, again the K2 value is varying based on the element that you take. Similarly, the map method is executed on all 10 lines, and it is finally producing the data which is of this form. This is called intermediate data, and this is the data that I pass it on to reducer. Okay, now let's come to the reducer. What is reducer? Reducer aggregates the intermediate output for multiple map methods to generate the final output. Okay, now since we are talking about the distributed programming, we only spoke about one instance of mapper running on a one particular slave node, but nothing is stopping us to run the same map method on multiple name nodes, sorry, data nodes. You remember when we talk about a file called file.txt, it gets broken down into multiple blocks, and each of these block goes and gets stored on one particular slave node, right?
Yes. Yeah.
Okay. So I also talked about a concept called data locality. Okay. Let's see what is this data locality again. Let's say this is my cluster of 5 nodes. Let's say I had a file, and that file is stored here. 3 blocks. Okay, the file.txt is broken into three blocks. This is slave 1, slave 2, slave 3, slave 4, slave 5. Okay, when I say slave, internally it has data node, it has job task tracker. Here master has name node as well as job tracker. For simplicity, I have put a Hadoop architecture. Now the whole of this computation, when I want to do on a file, this file, let's say whatever text we have seen here, right, that file is actually broken down into 3 blocks, block b1, b2, b3, which means the whole of this operation that we did as a part of map has to be done here, here, here. Okay, the same processing is done on 3 slaves, and doing the computation on the data node where the actual block is stored, that is what is called as data locality. Do the computation on the node where data is stored. You remember this was one of the feature of Hadoop.
Yeah.
Okay,
The data
now
doesn't has to travel.
yes, you are right. Now we may ask a question saying that what if S1 is busy? In that case, I can schedule the computation request here. There is a task tracker here which is sitting free. I can tell, the job tracker can tell to this particular task tracker saying that, can you execute a task for me? But the data is residing on slave 1. So in that case,
Hmm.
this guy needs to talk to this particular slave, get the data and do the computation here and generate the output here. Okay, this is not data locality. Whereas when you move the computation to the slave where data is residing, that is called data locality. Okay.
Okay.
Yeah,
Yeah.
that the same computation whatever we spoke here, right, it is actually now running on 3 different slaves. Okay, now let's see what's happening in the reducer. I'll keep this diagram as it is. In reducer phase, what it
Hmm.
is trying to do, it is aggregating the intermediate output from multiple map methods. The map method is running here, the map method is running here, the map method is running here. 3 instances. me see if I can pop oh shucks, man. I erased it. Okay. I didn't want to erase, but okay. Okay, so we had actually three slaves where the computation was happening. In reducer phase, what
Mm.
happens is the framework, the MapReduce framework will take the output from all these three map methods and then pushes that output to a slave where the reducer is going to run. Okay, and for reducer, I'll come to that. So I have a diagram for that. I'll show you a bigger picture later on. The output of all map methods will be pulled onto a different slave. On that particular different slave, we now execute a different Java method, and that particular Java method is called as a reduce method. See here. So what is reduce method? Mathematically, the representation is this: reduce of K2 list V of V2, which generates a final output, which is again a list, which will have a different key and a different value compared to your inputs, compared to your original inputs. Okay. Whereas if you see the output of map and input of reducer, the keys are same. See this? I'm
Mm.
maintaining the key as same. The only difference is the value is becoming a list now.
Uh, okay.
Okay, let me show you. This comparison you are able to appreciate, right? The mapper input is
Yeah.
K1 V1, the output is K2 V2, and reducer input is K2 V2. For simplicity list, I'm ignoring K2 V2. The output is K3 V3, which means all the keys and values are different at all the phases. Okay, so
Yeah.
when I sequentially, if I draw this is how it is looking like. Okay, this is how it is looking like. This is your K1 V1, this is your K2 V2, and this is your K3 V3. This is how it looks like. Okay, now let's go back to our example of a Baba black sheep.
Okay.
Okay. Uh, Hey, just a small point. Yesterday I was talking about Hive in Scoop, right? Can you try yourself, importing the data to the Hive table? Okay. You should use parameters like this. Yesterday I showed it to somebody else, so